Balancing equations using half reactions in basic solutions. Number one, you got to assign the oxidation number for each atom for any oxidations and reductions. Balance right away using half reactions. Continue to balance up to hydrogens and oxygens. Any oxygens you need to balance, you do it with H2O. With any hydrogens, you do it with hydrogen ions. You then have to add OH minus to the hydroxides to both sides equal in number to the amount of hydrogen ions present. You combine any hydroxides with hydrogen ions in order to make H2O on the same side, and then you cancel out any H2Os on both sides. You then balance the net charge by adding electrons and make the electrons gained equal the amount of electrons lost. You then finally add the half reactions and cancel any like terms. In this question over here, as you can see, this is an oxidation number of 7, and then our manganese here has an oxidation number of 4. It reduced, so there was a gain of 3 electrons, the difference between 7 and 4. However, for this one over here, C2O4, as you can see, we have to add some oxidation numbers. So this one would have to be a 3, this one would have to be a 4. Okay, so with 3 to become a 4 is obviously a difference of 1, so it lost 1 electron. We're just going to separate these into half reactions. So we're doing this and this one together over here, and this one, and this one, and this one together over here. For oxidation, as you can see, they are balanced because I'm adding a 2 in front of the CO2. Now they're completely balanced in terms of our oxygens. There are no hydrogens, so we don't have to worry about that. So we can actually skip number 3 and number 4, and we can get all the way up to number 5 by balancing by net charge. So as you can see, this is a -2. This here doesn't have any, but if we add 2 electrons, now this is a -2, and they're both balanced on both sides. For our reductions, it's not that simple. Our oxygens are not balanced, so we're going to be adding it with H2Os. I added 2 H2Os here because there are 2 oxygens, so now 2 and 2 gives you 4, as like that. Okay, but however, this messes up our hydrogens, so now there's just 4 hydrogens over here, so I'm going to add 4 hydrogens over here. But you got to combine OH minuses with the amount of hydrogen ions there are, so we're also going to add 4 OH minuses there. You got to do it on both sides. So put a 4 OH minus over here, I got to put 4 OH minus over here. I can then add the OH minus and the H plus together to give you a 4 H2O, but now we have to make sure that our charges are the same, okay? This one has no charge yet, so this is a -4. This one over here just a -1, so I'm going to add 3 electrons to give you that -4 and -4, okay? And then you can cancel out your H2Os, okay? So there's 2 H2Os here, 4 H2Os here, so there's a leftover of 2, and this is going to be all gone. So now we have to make sure that the electrons are the same. This one is a 2 electron, this is a 3 electron. Obviously, lowest common multiple is a 6, so I got to multiply this whole thing by 3, multiply this whole thing by 2. As you can see, multiply it all by 3 over here, multiply it all by 2 over here. We got any like terms? Yep, 6 electrons, so these can go away. So I've added here as our final answer. Try this one and try this one on your own, and I'll be giving you the answer shortly. This is the answer to the first question. I will slowly scroll down. This is the answer to the second question. I will slowly scroll down.